So another algorithm for sorting an array is the selection sort. It's also relatively simple, and again, it's not the best sorting algorithm in the world, but it's simple enough that I can actually explain it to you. So let's go ahead and do that. We have our array that's not sorted right now, and the basic idea of the selection sort is to continuously look for the smallest number and put it at the front of the array. Okay, so I start by looking at the first number. 3 is anything lower than a 3. 5 is not lower. 1 is lower. Anything lower than a 1. 6, 2, 4. No, 1 is the lowest. So what I do is I swap that with the first position of the array because that's where it belongs. Okay. So now I'm looking for the second lowest number. So 5, is there anything lower than a 5? 3 is lower than a 5. Anything lower than a 3? 6, no. 2 is lower than a 3. Anything lower than a 2? And 4 is obviously not. So it's the 2 that needs to swap with the second position. Okay, so we make that change. All right, so now we're looking for the next lowest. Okay, we're starting off with a 3. Anything lower than a 3? 6, 5, 4. No, it's good. So it stays where it needs to go. Anything lower than a 6? Yep, 5 is lower. Anything lower than a 5? 4 is lower, so obviously 4 is what needs to get swapped into that position. All right, so I can tell that it's sorted already, but I'll go through the final step any rate, which is looking at basically the last two. Do these two need to be swapped? Okay, so is there anything lower than a 5? Nope. So it's good. And that's basically the selection sort. So back in my array templates header file, this is the implementation of the selection sort algorithm as a function template. Again, I'm bringing in array values and a size. I'm keeping track of a minimum index. So that's where I find the lowest value of whatever subset of the array that isn't sorted yet. I'm also keeping track of the number of moves, so we'll be able to compare it a little bit against the bubble sort, at least for this particular array. Okay, so for each element in the array up to the second last, I set up a little loop. Okay, what I want to do is once I go in there, I want to find the minimum value index, and I assume that it's the one that I'm on. Okay, then I go through a loop where I'm actually proving that it is by comparing it with the next index. So the next index starts off as the next one over. Okay, and while I don't hit the end, I go up by 1. If the value that I'm on in the next index is less than the value at min index, then I want to record that. That's sort of temporarily, potentially the new minimum. Okay, not quite sure yet, but I go through back up to the top of the for loop, and that continues to the end. Once it actually exits the for loop, I know that min index is actually the lowest value of what's left in the array. So then I have to make a quick decision. Okay, um, do I want to swap it? Okay, so if the value at min index is less than the value that I'm on, okay, um, where this would be false would be if we have two numbers that are the same. Okay, so we swap them using the same sort of algorithm I used before, and I increase my moves by 1. Okay, so then we go back up to the next index and we start the whole process over again. So in my main, I'll use the same sort of code I used for the bubble sort, where I was displaying how many moves it took for selection sort to do its job, and then displaying the array again. So let's run that. Okay, so we can see selection sort certainly sorted the array. However, instead of 21 moves, it only used 7 moves. So in this particular instance, selection sort was way better than bubble sort for what we needed to do.